Okay, Matthew, who are you and what do you do?
I'm Matt Weller, Survey Manager with Monument Geomatics, part of Monument Group, and we are surveyors and engineers. This is a Trimble X7 survey grade terrestrial scanner that we use to collect data in the field for design purposes on engineering projects.
And this is an example of a robotics type of technology, like a total station. Can you describe what that is?
Yeah, so it's a survey tool that we use to collect, in this case, millions of points in 360 degrees. It's a LiDAR scanner, so it uses light detection and ranging to extract information of everything that it can see. So from where we are today, we can scan 360 and we can extract information, for example, from this tree. We can get an idea of the diameter of the trunk, the diameter of the canopy, the height of the tree, for the purposes of a tree survey, for example. On the engineering side of things, we've used this to do full 360 scans of bridges, where we can then take the information that we've captured and extract all sorts of information that's useful to engineers for designing a replacement, for example, of a bridge. So it has a multitude of uses in our industry.
Okay, now here's a follow-up question. The Ganaraska Region Conservation Authority has funding to upgrade the floodplain maps in Northumberland County, and they have over 700 culverts and bridges that they need to scan in order to do the hydrologically conditioned mapping of that watershed. How could you save time with this technology to map out those bridges?
The traditional survey methods might be using a total station where we would have to set up and traverse over a period where we would have to make sure we're two or sometimes three person crews setting up, checking. This is a very user-friendly, easy, time-saving tool that we use to efficiently scan what we need to do. Going back to, again, of a recent bridge that we did, we turned what would be a 2 or 3 day process into a 6 or 8 hour survey. So it's an extremely efficient tool for that, and still yields a very accurate data set that we can use for design and engineering.
The engineers love their contours, and if you give them millimeter accuracy, they're just going to fall in love with your work. And the other thing is, this is an example of the manufacturing plant of the future where they're using what are called cobots. And this, in a sense, is a cobot taken outdoors. The cobot works within a workflow with the humans, rather than the humans being part of the robotics workflow in a manufacturing site. And they're actually designed to work safely with humans by their side.
Well, it needs me to push the buttons, so.
Yeah, yeah. Push the buttons, but also you're also ground truthing that information because you're out there observing what it's observing. And if the observations don't jive based on your knowledge, then you can challenge it as well.
That's right. I mean, there's always a benefit to having boots on the ground in any survey that you do. So it's not too uncommon from that, from going out and doing a traditional survey and taking pictures to accompany, for example, the size and shape and condition of a culvert. This does it all for us. So with the push of a button, 3-dimensional scan, we're not only getting LiDAR point cloud data, but we're getting full panoramic images where we can then put that onto a desktop computer, zoom in, get all the information, all the pertinent information that we need from that data set. It's not just points on the screen anymore, it's a full 3D rendering of our environment.
So with that 3D rendering, I think they call it photogrammetry surveying, and you create the point cloud. But this is with LiDAR, so it's not...
Remote sensing.
It's remote sensing with the LiDAR. Now, how long does it take to get this point cloud into a CAD program to do design work?
As long as it takes to dump a few gigabytes of data from the tablet to a USB stick and the USB stick to a computer. So once I have the data set, I put it into, in this case, it's a Trimble product, so we use Trimble Business Center to extract the information, to classify the point clouds. And it's It's hard to give an example. If I was just interested again in this example of this tree, a workflow like that might take me, less than an hour to extract all that information that you might need for these trees in this area.
And landscape architects, what kind of CAD program do they use to design landscapes with that scan that you provide them, the point cloud?
I think there's a number of softwares that they can use. The beautiful thing about the data that this generates is it's a universal file format that can be used in a number of different software. So again, we use the Trimble Business Center, but we also have Autodesk and Civil 3D, where that data can be exported into a file format that reads, and then you can use that if that's your platform that you use for design.
So we have a high school teacher here at St. Mary's Catholic Secondary School, and he teaches the kids robotics using Fusion 360, and he's also an AutoCAD teacher trainer this year. What we would like to do is take the scan that you've done with the trees here today and then bring it into his CAD program, and then they can design low impact development on the school grounds, both looking at the natural aspects or assets and the rooftops. And then they can compete for prizes in a hackathon coming up.
Great. It'll be a perfect tool for that.
Thank you.